So let's start with the first, a quick overview of what you have learned so far. Can you please tell me the difference between regression and classification? Can you please give me a quick overview of regression and classification?
This is basically used to predict numerical variables predominantly.
Which one is numerical? Which one is other things?
Regression is used for numerical values, and classification mostly for discrete values or the
Okay, so yeah,
categorical value.
that's good. So classification output is some specific class like 0, 1, but regression give the continuous value. Regression is the numerical. That's good. Please post your answer in the chat section. And this is for everyone, guys. If you are able to give, I mean, as you already have covered the machine learning things, so that will be like easy for me to cover the deep learning. And also, like I just want to check that how much aware you are or how much things you can remember about the machine learning. Okay, regression is it for the numeric, classification for the discrete. Okay, that's pretty good. Now my next question is, what is the loss function? You definitely saw this kind of a concept that we have some concept like loss function. So I just want to know that what is this loss function? Because same loss function concept I'm going to use in the deep learning as well.
And the error that we try to minimize while building the model.
You can post in the chat section also, the learners who is speaking. So that will be good. Like you can post your answer in the chat section. Okay. And let me just check that. Please post. I'm expecting this answer from everyone because everyone has covered this machine learning concept. So I'm assuming that. So I'm expecting the answer from everyone. Okay. So loss function is some of their training example. Mean square error, actual minus predicted. Actual minus predicted. It's not necessary that it is always the actual minus predicted. We have the different formulas for the loss function. Okay, so I got the mixed response, guys. It is half correct. I was expecting Syama loss function and cost function almost same kind of things. We interchangeably use these things. Okay, let me just give you a small things. So if I talk about the loss function, so first of all, as I mentioned that loss function and cost function we interchangeably use. So both are same thing nowadays. Earlier, like when we start learning this machine learning things, so people start differentiating that no, this is the different one. But now, like we don't want to get confused between this loss and cost function. So we are keeping it same. But your answer is correct. Cost function is for the data set, entire data set, and loss function is for the instance. You are right. So what is the loss function? So loss function is nothing but a function which is used to calculate the loss anchored by the model. And based on the formula, we have the different formulas. You also have seen the RMSC, which is also a loss function. You have seen the MSC, which is also a loss function. You have seen the MAE, which is also a loss function. You have seen the cross entropy, which is also a loss function. So if you see these things, if you remember these formulas, we are not using the difference actual minus predicted. One of the formula we are using it, but it is not necessary the difference between actual and predicted. If somebody asks you these things in the interview, don't say that this is a difference between actual and predicted. You should say that loss function is a function which we use to calculate the loss anchored by the model, and based on the different type of problems, we have the different type of loss function. So can you please tell me the loss function for the categorical problems? Can you please tell me the loss function for the categorical problems?
Entropy values.
Which one?
Entropy values and Gini index.
These are the loss function or the concept of homogeneity. You are 50% right, but Gini index things are not the loss function. Please post your doubt in the please post your answer in the chat section. Logarithmic loss cross entropy, yes, it is correct. What about other learners? Please post your answer in the chat section. Yes, so for the categorical problems, we have the log loss or the cross entropy loss, logarithmic loss. And can you please anyone give me the formula as well? Can anybody give me the formula as well for this loss? Can anybody give me the formula as well if you are aware of this formula? Y log hx1 minus y log 1 minus. Yes, correct, Samuel. Perfect answer. So it will be like y1 log p1, you are giving it for the categorical part, plus y2 log p2 up to yn log pn, where y1 is the actual probability and p2 is the your predicted probability. Okay, this is we have in the log loss. So now the next question is so we are done with the log loss machine learning. Now the next question is, which is very, very important, is how we are what is this hyperparameter tuning? In this deep learning also, I'm also going to use this concept hyperparameter tuning. It's a hyperparameter tuning. So can you please let me know what is the concept of hyperparameter tuning? The thing is, like when you are using the decision tree algorithms, you know that in the decision tree algorithms, by default, it use all the features and created a overfitted model. Right? You have seen that by default, it created a overfitted model. So we have to perform the hyperparameter tuning. And what this hyperparameter? If somebody asks you that, what is this hyperparameter? The hyperparameter are the parameter. These are the parameter of a algorithm that control its output. It's kind of a regulator of the algorithms, like we have the regulator fan, which control the speed of the fan. Similarly, in the case of the machine learning, or in the case of the AI, I will not call it as a machine learning. In the case of the AI, the hyperparameter, the parameter of algorithms that controls its output. And Why we need to control this output? Because as I mentioned that if we don't control the algorithm output, the chances of becoming a overfitted model is very high. So in that scenario, I have to perform the hyperparameter tuning, hyperparameter tuning for getting features, for getting right combination of hyperparameter, getting a right combination for algorithm features, algorithm right combination of my algorithm features to create a stable model. To create a stable model. It's not like that we need the higher accuracy, we need the stable model. Okay, so we need the stable model, not like that we have blindly focus on the accuracy, because if we keep increasing the accuracy, you know that after a certain time these things will convert into the overfitting zone. So we cannot say that hey, we have to go to blindly increase the accuracy. My objective is to get a stable model. And you know that what is the condition for the stable model? So the condition is that your training accuracy and the validation accuracy, the difference between this training accuracy and the validation accuracy should be. So again, this is very important concept. I will request you to please revise this concept which I'm discussing today, because this things is very, very important from the interview point of view. Now, the next thing is probably you also heard about a algorithms which is the gradient descent. This algorithms, if you are not able to understand, also post your thought in the chat section. If you feel that Harish, in the ML lecture, I was not able to understand it fully, I can revise these things also. But if you already know this gradient descent, I'm expecting to just give me a one-liner about this gradient descent, why to use or when to use. Please, it is for everyone. It's not for a few learners. I just want to know from everyone. If you are not aware of these things, please type not aware. I don't have any problem. If you are not aware or if you miss this class of the gradient descent algorithms, please mention that not aware. I will keep this thing in mind and we will cover these things when we are covering the deep learning optimization. Okay, I got one response from the Manish. Okay. What about other learners? Okay, slope versus loss graph to find the optimal scope. Okay. Gradient descent is to find out the minima of the MSC. It's not only the MSC, Rakesh. It is any loss function. Rakesh, it is not limited to the regression things. Gradient descent is a algorithm for regression as well as for the classification also. Aisha is also give the right answer. Gradient descent algorithm used to try the minimize any function. Okay. Yeah, class V is right. Sorry if I mispronounce your name. Sivraj used to get the best whittle line, very less loss. Yes, Karthik is also give the very correct answer. So, I mean, I was expecting these things from you guys, that First of all, you have to just mention that gradient descent is another optimization algorithms. Okay, it's not like that. I mean, I saw means although your answer is good, I'm not saying that your answer is incorrect, but your answer is not up to, or you're not pointed answer. You are just mentioning that we are just finding the right best fit line. This is not the case that we always use for the means gradient descent is only for the regression problems. So the right answer is, I think Karthik gave the very right answer that hey, this is a optimization algorithms. This is a optimization algorithms, and what I'm expecting from you is apart from this thing that hey, this is optimization algorithms, it is just used. It is used to find the optimal weights, optimal weights for my model equation or my model parameters. That's it. How we are reducing the loss, this is the internal mechanism of the gradient descent. If you are somebody mentioned that Harish, we are plotting a graph between loss function and the coefficient. Yes, this is all are the internal mechanism of the gradient descent. But if somebody asks you a one-liner about the one-liner about the gradient descent, it's a simple optimization algorithms that is used to find the optimal weights for any model parameters. I am just, I have a model which is parametric model, which is the parametric model. So for this parametric model, I need to find out the optimal weights. And for these things, we have the gradient descent algorithm. That's it. Now it's clear? This point is clear to you? Tell me, guys. Okay, great. Okay, that's good. And now we start with the some basics of the deep learning. When I say the basics of deep learning, I'm just today I just give you a small few examples and few history of the AI just to create the interest. Okay, so maybe you feel that Harish, you are not covering any topics in the deep learning. I just want to show you that what is the deep learning and where we can use this deep learning. Okay, so let's start with the some kind of a history of this deep learning things. Can you please let me know if you are aware of these concepts like Turing test, some basic things, how the deep learning evolved? If our sir is already explained this thing in the machine learning part, please let me know. If sir has already explained these things in your machine learning things, then I will just avoid these things. Please let me know if sir is already explained these things. Okay, no. Okay, so let's understand, guys. Let's understand that how the things evolved. Okay, so let's understand that how the things evolved in the field of AI, so that it also increase your interest in the AI, and also you will be also aware that how the things evolved over the period of time. So this AI concept is not a new concept. Maybe from the last 5 to 6 years, you start you start getting this concept that hey, AI is there, it will replace the human, something like that. But it's not the new term. AI was a quite old term, and it was first published in the one research paper that is proposed by the Alan Turing in the 1950. So they just give the idea, they propose a concept. They proposed a concept that can machine also think like a human? When we talk about this thinking means that can machine take the independent decision? When I say the independent decision, it means that can machine take the decision without any human intervention? Because if you see these things, whenever we create a software is nothing but a collection of rules. Am I right? If you talk about any software, guys, that you are creating, this software is nothing but a collection of rules. Yes or no? You are just implementing your business logic, right? So a software is nothing but a collection of rule which is implemented by the human or a software developer. But in this research paper, they mentioned that instead of writing the software, instead of writing these rule-based things, can machine create the rules by themselves and they can implement on the data? So this was the first approach is in the Alan Turing. And in this Alan Turing research paper, this research paper was like he just mentioned, he created a machine during the World War II, and that machine was responsible for the Hitler defeat. I don't know whether you are aware or not. So the main reason of Hitler defeat is that the encoded message that was shared among the army in the German army, Alan Turing created a machine which automatically decoded the Hitler's secret messages. And it was a very big reason behind the Hitler defeat, guys. Because by that way, England was able to France, I think this is England, right? So they are able to find out that what was the Hitler plan when, like, means they understand the each secret messages that is being passed between the German armies. So they were able to decode these things, and due to these things, like there was a huge loss, and this was the reason behind the German army. And based on these concepts, there is also a Hollywood movie also. The movie name is, I think, Imitation Game, something like this one. Let me just check it. Okay. Let me check these things. It's a very famous movie. Alan Turing. Yeah, Imitation. Yeah, Imitation Games. Yes, this is the one, guys. So movie is based on the same things. So here they just mentioned that how Alan, I mean, this is they also add the some personal lives of the Alan Turing also. But the main concept that you have to focus on the way that he created this machine, and then after that, how the machine was automatically decoding the Hitler messages. So if you have some interest in this AI thing, so you can check this movie also. It's a single times watch movie, guys. Okay, so it's a good movie. You can see. Then after that, over the period of time, then 1955, John McCarthy is also introduced the term artificial intelligence in a conference, and then from this evolution of AI had started. Then after that, there was slowly improvement in the field of AI, and from the 1956 to 1974, we are getting some kind of a small improvement in the AI. And then after that, very first times in the 1997, IBM created a machine which can fight or which can play against the human. And you know that Gary Kasparov is a very famous chess player. And in the 1997, so IBM developed a machine which played against the Gary Kasparov, and Gary Kasparov was defeated in this game in the 1997. But that thing was again not the machine learning things, it was just optimization of the algorithms. Means that they created a machine which can which is very very optimized, and which can think about the multiple steps, multiple combinations when your opponent is taking any steps. So it is just doing the optimization to see that what are the different steps are possible, and lot of permutation combinations doing. But that was a kind of a machine. So this was also a good breakthrough in the field of the machine or machine learning, you can say that. And we start after that we start improving our machine and start introducing the algorithms. If I talk about nowadays we have kind of a state of art in the AI. Almost AI is available in almost every field. AI is available in the field where it can recognize the human faces. And in the Singapore, I don't know whether you are aware or not. So during the COVID case in the Singapore, like in India, we have the our volunteers or the police forces on the road during the COVID time uh, to uh, to persuade the people to stay at home. But here in the Singapore, they have this kind of a people robots which just check that whether people are following the social distancing or not. And if someone is not following the social distancing, they are also putting some challan as well. Have you heard about these things? This thing is already implemented in the Singapore, and now based on the similar concept, now in many stores we have this kind of a robot assistant. Apart from these things, yes, in the healthcare systems, we achieved a very significant kind of a achievement where AI-based machine can perform the small surgery, not the crucial surgery, but yes, the basic surgery it can do. Apart from these things, we have a lot of AI-based things, and nowadays we are surrounded by almost all the application having AI. If I talk about nowadays, your mobile is your AI base nowadays. If you see these things, that if you simply search a some news or some articles on the Google, in the Google search, Google start recommending you the similar search. Have you observed these things? If you search a article in Google search, Google start recommending you the similar kind of a news. Like for example, I'm interested in the I'm interested in the Ukraine-Russia war, that what how the things are going on in the between this Ukraine and Russia. So after this article, behind the scene, Google Chrome is using AI model which automatically check your history and start giving the recommendation based on your history. If I talk about the language translation, so language translation is also very huge breakthrough in the field of the natural language processing. So in the field of the natural language processing, maybe you remember, like I can remember my college days where, like if I want to watch any Korean movies or English movies, we have to download the SRTs. We have to download this SRTs, which is nothing but the text file for the subtitles, and then we have to upload this SRT in the VLC player, and then I was watching the movie with this English subtitles because we didn't have any kind of a real-time language translation. But nowadays, you know that we have this real-time translation. I think Zoom is also having these features of the real-time translation. And if we talk about any OTT platforms, all these OTT platforms is also using these real-time translations. YouTube is also using this real-time translation. So I think this Amazon is also using, I don't know, sorry, this Zoom is also using this captioning things. I don't know how to enable it, but yes, your Zoom is also using this kind of a things. Yes, transcription of MS Team is also the AI language translation. So these are the few examples that we have in the AI. Almost in every field, we have the AI. What AI can do? Yes, AI can do the superhuman task. AI can perform the repetitive task and the data sensitive task. What is the advantage of the AI? Yes, error reduction. So now we are know that like we are humans and the chances of error is there in the human. So, but in the AI, so the chances of error is less because it is totally based on the uh, your model performance. It is if your model is accurate, the chances of error is very low. Apart from these things, like you can use the AI in almost every sector. As I mentioned that it is used can be used in the healthcare sector, banking sector. I'm also working in a for a bank. So we extensively using the AI in our projects. We are creating the projects for in the NLP area to perform the some kind of a text extractions to perform some kind of a NER model. So have you completed your NLP classes also? Can you please confirm that have you completed your NLP classes as well? Okay, no need to worry. Okay, guys, thank you. I just want to know. Okay, no problem. Okay, so like in the NLP, you will see that how we can process the text data. So AI can be used to process the text data and build some kind of a sentiment classification model, some kind of a clustering models like this. If I cover the recap of the machine learning recap, we already have seen that we have the supervised, unsupervised, and the reinforcement learning. So, okay. So we already have seen that in the classification, we have the categorical part. In the regressions, we have the numerical value predictions. We have a target column, which is numerical in nature, and which we have to predict. Then in the case of the supervised machine learning problems, you have seen all these algorithms, you have seen the linear regression, you have seen the logistic regression, spot vector machine, the naive Bayes, decision tree, LDA, all these algorithm that you have seen that. Then after that, you also have seen the unsupervised machine learning problems also where we are doing the clustering or the association to build the multiple models. And if I talk about the algorithm that we have in the unsupervised, we have the k-mean clustering, we have the hierarchical clustering, we have the PCA, we have the DB scan. So can you please tell me the how the PCA works? What is the use of the PCA algorithm? Okay, yes, it is the dimensionality reduction. Can you please give me a small introduction about the PCA in the one-liner introduction of the PCA? Feature having the correlation, find the orthogonal feature which represent the no. Manish, you are aware that, are you aware that PCA never gives the feature back? Are you aware of these things, guys? PCA never gives the feature back. Yes, it gives the components. So don't avoid these feature things. So no, guys, please revise this concept. I'm just giving a one-liner things also. I'm just giving you a small things to just remove your confusion about the PCA. One thing that I want to tell you here is that in the PCA we are passing the features. This is very, very important from the interview point of view, that I'm going to pass the features in the PCA algorithms, and in the returns PCA is giving me the components PC1, PC2, PC3, PC4. We cannot say that F1 is equal to the PC1. We cannot say these things. Okay. And now I will just sort this component. I will perform the sort this component based on the variation covered by the component. Variation covered by component. These things I'm not going in the deep of this PC because I'm assuming that you already have covered these things. So how internally it works, so I'm not going that in this deep. So I'm assuming that like you already have the sufficient knowledge of this one. But the only thing that you have to keep in mind, you have to keep the two things in your mind, that first of all, that PCA never gives the feature back, and for the end features you will get the end principal components, and then you have to short these components. You have to short these components based on the variation covered by this component. Okay, so please just avoid this. Avoid the things like the features back. Okay, because if you tell the in your algorithm is giving the feature back, so it will be a negative thing in your interview. It's clear to everyone now? Is it clear now? Okay, I'm assuming then it's clear now. Okay, reinforcement learning, you already like you know that in the reinforcement learning, we have the agent environment concepts, and agent will take the action, environment will give the some kind of a response, and then after that my agent continuously learning from the environment, and a situation will come where my agent is fully learned and it is able to take the action. And now we are introducing the deep learning things. Okay, so I will spend the some enough time on this, the difference between ML and DL, because it is very, very important to understand that how the deep learning is different from the machine learning. Okay, so if you also have seen, maybe you also have seen this kind of a graph, that AI is the superset. AI is the superset. Inside this AI, we have the ML, and we have some parties also combining in the DL, means that some concept of the ML we also use in the DL. Apart from these things, we also have the NLP, which stands for the natural language processing. And then apart from these things, we have the generative AI nowadays, we have the generative AI, and we also have the reinforcement learning, guys. So now, till now, you have learned this ML concept. We will just see that what we have in the ML concept, and then we will see that what we have different, or what we have in the deep learning, and how the deep learning is different from the ML1. So in the case of the machine learning, you also have seen that when I have any image or any features about the car, so what I have to do is, so can you please tell me that which problem statement you worked on in the classification? Which problem you worked on for the classification problem, guys? Which problem was there? What was the problem statement? Can you please tell me the problem statement of your classification example? Any? Can you remember these things? Can you please tell me quickly, guys, what was the problem statement? Okay, loan or not? Okay. So you were working on a problem statement whether a person will get the loan or not. So if I talk about this, the sequence of this your machine learning problem statement. So remember, like you got the data set, you got a data set, and then after that, you are performing the predict admission or not. Okay, okay. So if you can you please tell me your machine learning life cycle? Can you please tell me your machine learning life cycle? Guys, can you please tell me the what is the machine learning life cycle? This is very, very important. I just want to know that from you that what you have done in the machine learning life cycle. So what was the approach that you implemented to solve a machine learning problem? Then we can compare these things with the deep learning, how the deep learning is different from it.
Like you first understand the problem, and then
Now you can paste the thing, you can just mention this thing in the chat section. Please mention this thing in your chat section. I got only one response so far. If you are not aware, you can simply type the not aware. I can just spend some time. Otherwise, if you are already aware, you can just share this thoughts. I just want to know that how much that you are aware of this one, and if there is any misunderstanding, like we have seen for the PC, you had some misunderstanding, and for the gradient descent, I found some misunderstanding that you have. So please, if you are not aware of this concept, please type the not aware. One of the learner mentioned the not aware. And if you are the aware, please paste in the chat section that what is the life cycle. If you're not aware, simply say not aware, guys. I don't have any problems. I will cover these things. Okay, few learners mentioned the not aware. Okay, let me just give a quick overview of these things. So when we talk about a machine learning life cycle, so it start with the importing the data set, import data set. Then after that, you are performing the data exploration. And then after that, you are performing the data exploration. After the data exploration, you found some kind of issues with your data. Then you perform the data cleaning. And then after that, you are doing the feature engineering. And can you please tell me that what we are doing in the feature engineering? Can anybody tell me the feature engineering? Then after that, we are implementing the right algorithms. We are implementing the algorithms. And then after that, we are perform the model testing. And if everything is good, we will perform the model deployment. So this is the role of a data scientist. So data scientist has to take care of the entire life cycle. So it has to start from the import the data set to the data exploration, to the data cleaning, feature engineering, implement the algorithms, model testing, and this one. So I was expecting that what you are doing in the feature engineering. This is the important part. So if you remember, I think definitely you already have done these things in the machine learning. So you can remember that in the feature engineering, you are just creating the new column, creating new columns, or performing the dummy variable conversion, like these things you are doing. Yes, removing the duplicates, combining them, creating the new features. So these things, we are a data scientist is doing this feature extraction manually, or you can say that you are doing the feature extractions explicitly for this data, and then after that you are implementing the your algorithms. Like for example, based on the features, you want to differentiate between whether this picture is a car picture or not a car picture. So in this type, or for this type, we are creating some features, like whatever the feature that we got in the beginning, we perform some feature extraction, and then after that, we implement the algorithms to perform this classification. But how the deep learning is different from the machine learning? In the deep learning, this feature extraction and the classification is automatically done by the algorithm itself. And in the deep learning, we call it as a network. We are not we in the deep learning we use the network like CNN, convolution neural network, RNN, ANN. So like these things, we introduce the concept of the network here instead of using the algorithms. So how the things are separate here, the things are is that in my deep learnings, my algorithms, not the algorithms, my network will take care of the feature extraction. I don't need to create the dummy variable. I don't need to create the I don't need to create any kind of a new features. I don't need to convert into the dummy variables. I can just get the data and pass to the model and let my model learn the things from. Let the network learn from this data and create their own feature engineering. This is the major difference between the machine learning and the deep learning. This is the one major difference. So this part is clear to you? Okay, great. The next part is, which is also a major difference between the machine learning and ML in the deep learning. And one more thing is, guys, I will take this class till 9:30 today because, so, like, suddenly I got that I have some travel emergency. Like I have to leave somewhere, leave for okay, so I have some small emergency, guys. So what we can do is I will just take this class till 9:30 today, and the remaining 30 minutes I will compensate in the next lecture by increasing the time slowly for 10 to 15 minutes in the few next lecture. Okay. So sorry for that. Like I just recently now I got this thing that I have to travel somewhere. So this 30 minutes loss I will just compensate in the upcoming classes. But let me just focus on this one. So if I talk about the machine learning, if you remember that while building this classification model, you are only using 10 to 15 features. Am I right? You are only using the 10 to 15 features at the time of building the model. Yes or no? Quickly, guys, please tell me these things quickly. And on these things, you are implementing the algorithms, right? If you have, like, for example, Harish, we have the 150 features. So if you remember that when you have the 150 features, you use the RFE algorithms or PCA and reduce to the 10 to 15 features. Means that finally, at the time of implementing the algorithms, you are using the 10 to 15 features only. But, and most of the times you saw the data into the CSV file. Am I right? You saw the data into the structured format. You store the data into the structured data basically, which contain the like row table kind of a things. But nowadays, especially after after this Facebook, social media things, nowadays we have the data in the form of the text as well as the image as well. Before that, if I remember that, if you remember the time before 2009, we didn't have any Facebook. We had the Orkut, which is very limited things. And so at that time, before this Orkut thing, before the social media thing, we had the data is in the very structured format. We have the data in the form of the Excel sheet. We don't have the much data in the form of the text data, or image was very limited, and YouTube is also very limited, guys. But after the social media things, now we have the Twitter, we have the Facebook, we have the Instagram, where user can upload the images to share the thoughts. User can write the text, they can write a post to share their thoughts. So after the social media, so this text or image data is also exponentially increased. And in this way, to understand the customer behavior, now we have to process the text data or image data as well. I want to see that whether somebody is writing a negative comment or not, or some abusive language or not while writing a post. Twitter is already doing these things. Or if you are upload a wrong image or the nudity image, the image which contains some nudity over the Facebook or not. So Facebook is already doing this kind of a things. And I don't know whether you heard this news or not. Recently, I think last year, one of the person, like someone in the India, he was doing the suicide. He was doing suicide, live suicide through the this Facebook Live, right? So he opened this Facebook Live feature and creating this live suicide video. And then this Mumbai police, I think this happened with the Bangalore or the Mumbai. So Bangalore police, I think it's for the Bangalore. So Bangalore police got a call from the Facebook, where the headquarters is, I think, in the Ireland. So they got a call from the Facebook that someone from the India is uploading a suicide video, and it's doing the live suicide video. And then they Facebook shared the coordinates or the location of that person house from where he is operating the Facebook, and that Indian police reached on the time and they just saved the person. Have you heard this news? This is the live example or the live good application of the AI, how AI can save a human life. Yes, somebody mentioned these things, right? So nowadays we have the data in the form of the video or image also. So to analyze these things in the real time, this thing is not possible with the help of the machine learning things. And that's the one of the another reason is that deep learning came in the market, or deep learning is nowadays very popular. Because when you are, if you see, just remember, just see that, guys, somebody is doing the live streaming of the suicide, and analyzing this live streaming in the real time is very difficult. Lot of people are uploading the things on the YouTube or the Facebook live. Analyzing this thing in the real time is very, very tough. And this is where we are creating some complex architecture. So the another use of the deep learning is to create some complex architecture, complex network where we can classify or we can process the image data, video data, or high complex data. So this kind of a things is also the another reason behind that why we are mainly focused on the deep learning. Nowadays, deep learning based architecture we are using in the generative AI, like it's a chat GPT, you have the chat GPT bard, GitHub Copilot, all these things behind the scene depend on the deep learning architecture. We don't use the traditional machine learning things nowadays because we have very complex problems. Small problems, machine learning is okay, but for the complex problems, we still rely on the deep learning nowadays because the architecture, because the problem is complex. If I talk about the language translation is very, very complex problems. For a one sentence, it is okay. But if you want to do the real-time language translation from Hindi to English, Hindi to Turkish, Hindi to Korean, it is very difficult. So for these things, we need the deep learning architecture. So to cut this story in short, I will say that deep learning is the field of AI which is solve a complex problem which generally not solved by the machine learning. And in this deep learning, we use the concept of the network to create a complex network or a complex architectures to learn from the input. This part is clear about the deep learning. I have given you some examples. The Manish also shared this article. I suggest you to go these things. You will also see the power of the deep learning. Behind the scene means like deep learning architecture is being used to process this video classifications. Okay.